Welcome everyone. Today we are going to talk about ransomware infections in cloud databases. First of all, I'm very thankful to Texas Cyber Summit committee members for giving me this opportunity to talk about this research. I'm also thankful to all of you who are attending this talk. I hope we are going to have a great time during this talk. Let's get it started. Before we move further, there's some disclaimer I want to talk about. The basic purpose of this research is to share the intelligence with the security community. And the target is to strengthen the efforts to build strong prevention and detection solution so that we can subvert these attacks on the internet. And we strictly believe that it is only possible when the security community comes together and work collaboratively. In order to do that, we have to share our findings, we have to share our research. And that is the basic target for this talk is. A little brief background of mine. I've been into this industry for more than 13 years now. I've written 2 books, Targeted Cyber Attacks and Empirical Cloud Security. You can check for my background more at the portal here. And you can connect me via Twitter as well. But the basic purpose to highlight the background here is to show that what we are going to discuss, we know what it is all about and how we really need to go ahead and solve those problems. So what is the agenda today? At first, we are going to look into cloud databases, threats and attacks landscape. Very important to understand what are the new trends and tactics that attackers are opting to target cloud databases. We will look into some of the root causes of why ransomware infections are happening in cloud databases. We will look into some of the real-world examples. After that, we are going to talk about 2 tools that we have developed, and we will demonstrating those tools against real and live targets on the internet to show how we can detect ransomware infections. And then we'll have our questions and queries down the line. So this is one of the most important and essential artifact in the real world these days. When I say real world, in the world of digitalization, we are talking about the internet. The ransomware attacks are rising exponentially. And why that is? The reasons are as follows. Because data is the new currency. Everybody wants to control the data. So as the attackers. Second is, why to launch attacks for free? If the attackers are going after subverting the integrity of internet and compromising systems, they really want some profit out of it, which means they want monetary gains. Combining these 2 factors, attackers are going after the technologies, exactly how the data is stored, processed, and transmitted. One or the other way, they want to control the data. And the main reason is data is the new currency. In the world of digitalization, whoever controls the data controls the money flow, and that is the reality. Well, that also enhances the security challenges for the organizations as well, because attackers are very much focused. And whenever they design a malicious code, they are designing in the form of ransomware. Basically, we're going to infect your systems, we're going to install ransomware, we're going to control your data, and at last, you have to pay us the ransom in order to get your data back. So, I control your data, you pay me the money, and then is all as well. That is the reality of the attacks on the internet. And that's why ransomware attacks are increasing at a rapid pace. So let's look into some of the cloud databases. In this part, you can clearly see some of the media titles that I have picked up related to Elasticsearch. You know how Elasticsearch servers are compromised, how attackers are launching attacks against these services, and more importantly, deploying ransomware in the Elasticsearch instances. Basically, they are going to control the data. They are going to control the search engine capabilities that Elasticsearch provides so that you won't be able to get access to your data. And ransomware is not the only one attack that these cloud databases are encountering these days. There are many more. But for us, we are going to focus on ransomware primarily. And you can clearly see, hackers are targeting Elasticsearch a lot these days. And this is one of a severe problem as well. So categorizing Elasticsearch into cloud databases is nothing new. Now, on similar note, we have another cloud database threats and attack landscape if we want to look into is the MongoDB. Again, some of these titles and news headlines actually highlight how severe the problem is. Cloud databases are under attack by attackers. They want to control the data, as we discussed earlier. And once they do that, they are in full control. So that's why these adversaries or attackers, they are going after cloud databases. So if you just look at from the technology point of view, both Elasticsearch and MongoDB databases are NoSQL 1. In Elasticsearch, we have an unstructured data so that they can query it efficiently. Similarly, with MongoDB, JSON-based documents are stored with proper collections, and you have to surf through these collections to do the interaction with the database. So if the attackers control that collection in MongoDB, they are going to control the data. And of course, they are going to encrypt it so that you won't be able to recover it, and which we're going to see in some time as well. Since we have seen the threats and attack landscape for Elasticsearch and MongoDB, which means in this particular talk, we are going to focus on ransomware infections that are targeting Elasticsearch and MongoDB. Our focus will be these two cloud databases, highlighting how ransomware are going to exploit these and how we have done definitive research to detect infections in these two specific cloud databases. So as a part of this research, we'll be discussing in detail about our two different tools. But let's first understand what are the root causes for this ransomware infections, primarily targeting cloud databases. There are many reasons for that. Let's go through some of them to understand why this is a problem. Here I have listed a couple of reasons which actually initiates the ransomware deployment in cloud databases, which means how attackers are going to compromise cloud databases. What are the reasons they are able to successfully infect these cloud databases with ransomware? One of the main reasons for that is the exposed database administrative interfaces. During deployments, administrators not pay much attention to the security, and as a result of that, the configuration stays insecure, which actually result in exposing database administrative interface, whether it's on different protocol communication channels such as HTTP or HTTPS or others, whatever they sport, they are exposed on the internet. And if they are exposed on the internet, attackers are in a very well situation to go after, fingerprint them, and try to exploit them. It makes the situation more worst when administrators use weak and default passwords as well, or maybe running the interface in an anonymous mode. So attackers can easily launch credential cracking and try to gain a complete access to the database administrative panels. Another way attackers going after these cloud databases, because they are running on specific network services, these services are not secure in itself. For example, TCP-based services that are supporting the communication with the MongoDB instance are exposed again on the internet. Attackers, what they do, they try to interact with this network service, try to fingerprint what are the inherent database software is being deployed, and they try to map that and try to figure out any vulnerabilities that exist with them. And of course, they are going to go after exploits after that to exploit any inherent vulnerability that is present, and then take a complete control of the network service, and at the end in itself is the cloud database. Another reason that adds to the compromise of cloud databases is via indirect channel, which means attackers first compromise the end user system to infect the cloud instances. We have standard attacks like drive-by downloads, and then many other ways, phishing attacks, where attackers are able to install malicious payloads on the end user systems. And when these end user systems are interacting with the cloud services, they try to control them through lateral spreading or other different techniques. But in this case is that attackers are going after end user systems first and then targeting cloud databases. Again, as I mentioned, lateral movement is the most important technique that is being used here, because once the malicious code is running on the end user system, it becomes way easier for the attackers to exploit or map other systems in the same environment. And that actually contributes further to the compromise of cloud databases running in the cloud environment. As we discuss social engineering attacks, of course, these are indirect way to compromise end user systems and taking that route to target the cloud instances running on the environment. So these are most important ideas that we really need to understand here, how attackers are kind of going after cloud databases in order to install ransomware. Attackers can go after any technique, but as a security researchers or engineers, we really need to be cautious on each and every front so that their appropriate security controls are deployed to circumvent these attacks. But that is the reality. Now, since we have understood how exactly ransomware is deployed in cloud databases, how attackers are exploiting the integrity of network services in order to control, now we really need to understand how infections look like in real world. Let's move forward. So what we are going to look right now is how the infections are being triggered in cloud databases and how exactly ransomware infections are mapped into these databases. We are going to take a look into 2 or 3 different examples here. Since we are focused on Elasticsearch and MongoDB, we are going to look into examples of infected Elasticsearch and infected MongoDB instances with ransomware, and try to understand how in real world these infections are triggered. So let's take a look into first example. So this one is an example related to Elasticsearch cloud instance. The highlighted details here reflect if your Elasticsearch instance is infected, how attackers are leaving ransom messages in the infected instance. In this case, you can clearly see the message highlights all your data is backed up. As we discussed earlier, data is the new currency, which means like the attackers have taken a backup and they have actually encrypted the existing state of the data. And they are asking for the Bitcoin in a specific time period if you want to recover it. If you're not able to provide that money, you're not able to recover your data, which will significantly impact the running services and in fact damage the brand of the organizations as well if they're not able to control the data, because it will substantially result in security breach. Now take a look into another example here. So this example is specifically for MongoDB. Now you can clearly see it is talking about one specific database here and what kind of different collections it has. So the collections are named as system.indexes as well as readme. So the most important part here is the readme. And the database name projected like readme to recover your data. So what's inside readme is the key here, which we potentially map it to as again a ransomware message. But subsequently, you can figure it out if you scan the databases that are available in MongoDB and related collections in it. You will be able to understand where exactly the ransom message is being left and what the demands of the attacker is. In this particular case, this actually suggests that how ransomware infections are occurring in MongoDB instances. And with the previous example, you will see how the similar infections are happening in Elasticsearch instances. Since we are focused primarily on two databases, Elasticsearch and MongoDB, so we really need to come up with a way to detect the ransomware infections on the fly, which means we really need to automate this process. So let's move forward to talk a bit more about it. In these sections, we are going to focus on two different tools that we have designed. The tools actually allow us to detect these infections running on remote instances of Elasticsearch and MongoDB on the internet. And we can use this for internal research purposes, as well as building some strong prevention solutions as well. But these tools gives you the capability to just detect, even as a part of your vulnerability management scenarios or vulnerability assessment, or even a part of penetration testing exercises, to detect whether these instances running in your environment are infected with ransomware or not. So these tools provide a great capability, and that's what we are going to discuss right now. So the first tool that we are going to talk about is STRAFER. So STRAFER tool provides you the capability to detect infected Elasticsearch instances with ransomware. So you can clearly see how the tool looks like, what kind of modules it supports, and you can clearly see there is one module related to ransomware, which will going to map the Elasticsearch instance against any potential infections specifically to ransomware. And we are going to see that in some time. So the first tool is the STRAFER one for Elasticsearch infections. The second tool is ENFILADE. It is focused on mapping the MongoDB instances, whether these instances are infected with ransomware or not. So if you can look at the different modules, it's for different modules. So it's not only related to the ransomware mapping, but it is also related to other infection scenarios like MioBot as well. You can check for admin access, privilege escalation. You can dump different set of information. You can verify the authentication configured. But our focus is only on the ransomware in this talk, as we have discussed earlier. Both of these tools will provide you the power to run the scans in an automated manner to unearth infections in Elasticsearch and MongoDB instances running remotely. So let's see how it looks like. So the first example is the STRAFER one. Exactly, the STRAFER is in action here. It is detecting in an automated manner an Elasticsearch instance which is infected with ransomware, and how it basically scans that exposed interface, and using built-in heuristics and signatures, it maps whether the system, basically the Elasticsearch cloud instance, is infected or not. As you can clearly see, it is able to detect that the remote instance is infected and what kind of ransomware message is being left there. And that's pretty cool because you can just use this tool, run against Elasticsearch instance, and then figure it out if it has been compromised or not. Similarly, another example is of ENFILADE. This one is targeted against a remote instance of MongoDB. If you look in the here, the output reflects that it is run against the TCP port 27017, and the module that is enabled is intrusive check ransomware. So it's going to perform a very intrusive check here. What happened in this case is dumping the identifiers for all the databases, which means what are the available databases. It is readme to recover data, admin config, and the interesting one is the readme to recover data. So what the tool is gonna do right now, it is going to scan this database for all the available collections and try to dump and check against the logic that has been embedded in this tool for detecting ransomware infection. And you can see that it is able to detect this ransomware infection, highlighting what is the content of that message, what is the ask of the attacker, and how it looks like. So overall, previously you have seen STRAFER. Now you have seen ENFILADE. These are some of the examples. But let's see how these tools act in real world. Now it's the time to go a little bit detail into the demos. The first demo that we are going to talk about is the STRAFER in the real world. Let's take a look. So right now, we are going to see STRAFER in action against a real world instance. It has many modules. But this one, what we are going to use is the ransomware one. So let's see. So the tool successfully detects the infection here. If you can clearly see, this is the IP running on a TCP port 9200, and it detects successfully the infection in real time. Because the remote Elasticsearch instance is infected. So what you can do here, you can download this tool and you can check for the state of Elasticsearch instances on the internet. You can even create a bash script, provide a multiple inputs for different Elasticsearch instances that are exposed on the internet and run this tool. You will able to find out that those exposed instances of Elasticsearch are infected with ransomware or not. Interestingly, you can clearly see there several patterns are mapped here: Bitcoin index readme, data backed up, Bitcoin account identifier, and so on. And once it just calculates a logic, it scans for this particular message and try to reflect that the existing state of that Elasticsearch instance. So this demo highlights how exactly STRAFER provides you a strong capability for checking the security state of Elasticsearch instances. Now, let's move on to the next demo. In this particular demo, we are going to run a very intrusive check against remote instance of MongoDB infected with ransomware. And you will see how ENFILADE helps to detect that in an automated manner. So let's first take a look into how the tool operates, different modules it supports, and all that. So first one, we are going to run potentially a basic check for ransomware. Let's take a look into that. So if you can clearly see, we are utilizing here 27017 TCP port, which is being consumed by MongoDB for its network connectivity. And now what you can see here is that we are able to detect initial fingerprints, and it is a potential way that this instance is infected. So the tool is saying run aggressive analysis. And let's just run the intrusive check right now and see how it reacts. So what the tool is now gonna do, it went inside into the database and checked for the available collections and whether any of that collection is infected. Basically, the attacker has controlled that collection and left over some sort of ransomware message. And now you can clearly see that the remote MongoDB instance is infected with ransomware. So we are doing a rerun here right now to highlight how it works. First, it was a basic check. It shows that there is some potential infection. And then we are running the intrusive check, which means that go detail into it, figure it out what it is, and then show me whether this MongoDB instance is infected or not. Now you have seen then a real world example and a demo of detecting ransomware infections against MongoDB. So just imagine you have these two different tools available for you: STRAFER for Elasticsearch and ENFILADE for MongoDB. You can utilize it for security research purposes, generating threat intelligence, launching mass scans for potential ransomware infections, and even conducting penetration testing, analyzing the security posture of your cloud databases, which in this case are Elasticsearch and MongoDB. So this is an automated way of conducting security assessment, specifically highlighting if these instances are infected or not with ransomware. So we develop these two tools that you can utilize in your regular work environment to reap benefits. Now, what is the inference here? So we strictly believe that subverting ransomware infection in cloud databases require defense in depth strategy and continuous security assessment in an automated manner. We need automation. The reason for that is the scalability aspect of it, whether it's vertical, whether it's horizontal. With that, with exponential increase of cloud and organizations are moving towards cloud technologies, they really need a strong infrastructure to support that. For that, they have to scale. And if they have to scale, so as the security has to scale. So in order to conduct and build a strong security posture, we really need to go after continuous security assessment, and that is only possible by automation. In this particular talk, when we discussed about how ransomware infections are geared up and attackers are targeting cloud databases, which are basically the low-level building blocks for any kind of different SaaS applications and other variety of applications. Protecting and securing these cloud databases are of utmost importance. And for that, we really need to go after assessing the security postures of these cloud databases, making sure that these are not being compromised by attackers. As a crux of this talk, we really need to detect these are not infected with ransomware. And that should be the target, making sure our data stays secure and we preserve our e-currency, which in this case is the data. So with that, you can download ENFILADE and STRAFER tools from these GitHub repos. It's open source. You can utilize the source code the way you want it to be and consume it accordingly. So both of these tools are available on GitHub. Go ahead, fetch it, use it, and share your feedback how you like it. Feel free to enhance it as well. Love to get your feedback on this, thereby making sure as a security research community we learn from each other, and that is our target should be. So with that, any questions and queries we can discuss off channel. You can connect me as well. You can visit my portal, which we have discussed earlier, or you can connect me via Twitter as well. I would really love to have your feedback on this one so that we can take it from there. I hope you enjoy this talk and we learn from each other, and you are going to use this research and intelligence in your regular work environment. Thank you very much. I really appreciate that. Again, I would like to be very thankful to Texas Cyber Summit committee members for giving me this opportunity to go after and discuss my research with you all. And thanks for creating this conference. It's amazing. I have been there earlier as well. And I hope this research talk gives you the valuable insights on how to go detect and circumvent ransomware infections in cloud databases. With that, thank you very much.